presenter for this before the break. I invite Federico Di Giacomo to present Touch the Sky, a multisensory planetarium to discover the universe. Federico, the floor is yours. I'll let you know when you have 2 minutes. Thank you very much for joining us with this beautiful topic.
Thank you very much. Can you hear me?
Yes, very well.
Okay, perfect. So
you can share your screen.
Yeah. Okay.
Perfect.
Can you see?
Perfect.
So, good morning, everybody, and thank you very much for the opportunity to be here today. I'm Federico Di Giacomo, and in this talk, I will present you on behalf of our interim working group the project, the idea, and a very first evaluation of a multisensory planetarium. So this project was realized principally by me and Stefania Varano, and I think that she is online now. So anyway, the main aim of this project is to offer to everyone, to every users, blind, visually impaired, deaf, or sighted, the possibility to observe the sky. And in order to obtain this, for this reason, we realized this multisensory planetarium, and we use many different. We integrate many different stimulus like acoustic, visual, and haptic one. So a very important and strong concept is the celestial vault. The celestial vault is the apparent surface of the sky, which many culture and myth intend as a sort of cover above the observer. This is only an apparent features that which the existence has been overcome by the modern scientific observation. But it still represents a very powerful idea with a strong social, cultural, historical connotation. Anyway, this concept is totally inaccessible for blind and visually impaired people that cannot observe the beauty of the sky. And so, in order to make the celestial vault more accessible to everyone, the multisensory representation, like, for example, sonification, 3D model, tactical model, play a very important role. And following this approach, we decide to realize a multisensory planetarium. So, the multisensory planetarium consists in a plexiglass dome with 1.2 meter in diameter. Okay, we decided to use this dimension because in this way everyone with their open arm can touch every part of the dome. And then the star in our planetarium is represented by this metal bar, and when you touch this metal bar, you can obtain many different stimulus, optical, acoustic, and visual one. And on the top of this metal bar here, we put a little LED that represent with the luminosity of the LED represent the brightness of the stars. And instead, in the bottom part of the bar here, we put these vibrational motors. This is similar to the vibrational motor that you can find in your smartphone or in other electronic device. And finally, for the acoustic stimulus, we use some different speakers that we put in some different part of the dome. And all these stimulus are realized by we use an Arduino board like this one to control all these electronic devices. And finally, we use many other electronic elements like transistor, connection cable, neoprene, and other elements. So, first of all, we decided to insert in our planetarium all the stars up to the 4th magnitude. This means that on the surface of the planetarium there are about 88, 89 stars. And in order to find the exact position of the star in the planetarium, we use a fisheye projection. So as you can see in this picture, here there is a projector with a fisheye, and here there are the different positions of the stars. We identify the position on the surface, and then we drill the dome, and in the exact position of the star we have decided to insert in our planetarium. And so then we cover the inner side of the planetarium with this black neoprene. Neoprene is the same material used for the diving suits. And the neoprene is a dual function. On one hand, it provides a black surface like the sky, and on the other hand, the neoprene block the effect of the vibration made by the different vibration motor. Then we connect, or we put the metal bar, the star, in the hole of the dome that we have realized, and then we connect all the metal bar or the star to the Arduino board. And this is the longest part of our work, because there, as you can see, there is a lot of connection, and is a very complex to realize the correct circuit, the correct element. So finally, we write the code and we upload the code directly on the different Arduino board. And this one is the final result. As you can, this is a picture of the inner side of the dome, where you can see the different constellation. There is the Big Dipper, for example, and so on. So in order to give to the users the possibility to explore the sky, and in order to give all the user or the same information about the characteristics of the star of the sky, we decided to adopt a particular mapping. So first of all, the information that we decided to insert in our planetarium are the position, magnitude, and distance. The position, the information about the position, it is given by the position of this metal bar that we can find on the surface of the dome. Instead, for the magnitude, we decide to adopt a dual, two different stimulus. On the visual one, we use for the visual information, we use a LED, and which the brightness of the LED is proportional to the real brightness of the star. And on the other hand, we use also an acoustic stimulus to give an information about the magnitude. In particular, we produce a sound with a different volume. Higher volume represents a brightness star. Instead, a lower volume represents a faint star. We decided to use this mapping because visual and acoustic stimulus the high and the high work with the same logarithmical scale, and in this way you can have the same difficulty in order to identify the difference between the same difficulty to identify if a star is a second or a third magnitude. Finally, we use also an haptic stimulus for the magnitude, because on the surface of the metal bar here, we put some different bolts, and the number of the bolts represent the magnitude of the star. Finally, the last information is so this is an example. So this is an example of the use of the different sound in order to represent the different magnitude of the star of Cassiopeia. Okay. So as you can see, the brightness star have a high volume, instead the fine star has a lower volume. Finally, the last information is the distance. The distance is connected to the vibration, and we use the vibrational motor in order to obtain an information of the distance. In particular, if the vibration is high, means that the star is very close to us. Instead, if the vibration is very, very slow, means that the star is far from us. And so finally, we decided to insert in the planetarium also on cultural information, and we use these red threads to indicate the different constellation. And so the people can follow this thread in order to identify the different constellation. So we use, thanks to this mapping, we obtain a dual cognitive framework. We use the acoustic and the visual stimulus to provide information based exclusively on the direct perception of the nature. This means that we use visual and acoustic stimulus in order to obtain information about the position and the apparent magnitude of the star. Instead, if we want to obtain more, instead on a second cognitive level is provided by the information obtained by the through astronomical instrument, like for example distance. We have to use another element. We use the touch to obtain information about, for example, the distance or the real magnitude of the star. So we present for the first time the planetarium show during the Viewpoint Festival in Rome, and here over than 100 of deaf, blind, and visually impaired people test this planetarium. Here you can see, for example, a little video where two deaf people touch the different star, the planetarium, and all the people that try the planetarium are very enthusiastic about it. And in this occasion, we make also some little interview in order to obtain feedback about the correct correspondence between the physical information and our mapping, and everyone said that there is a perfect correspondence between the information that we give in planetarium and the real information about distance, magnitude, and so. Here you can see some comments that we obtained during our interview, and so for me is a very important experience, and a very important comment is a woman, totally blind, that said me that thanks to the planetarium she have seen the sky for the first time. So finally, after this presentation, many Italian instructors asked to have a multisensory planetarium, and now we are working in order to make to write a blueprint with all the information in order to realize another multisensory planetarium, and we are working for a more complete evaluation about the characteristics of the planetarium. So thank you very much, and if there are some questions.
Federico, I'm just my mind is blown with with what you present. It's so beautiful, so amazing. We have in my organization Nucleo, we have a project called Dome, where we have produced, the idea was that we have cardboard planetariums, not our idea, copying from others that exist online. and that schools could build their own planetarium. You'll be bringing it to a whole new level. We will certainly contact you. Actually, David was part of the team of Dome, was the name of our project. And he's mentioning, amazing, I love it. Another interesting sound mapping protocol could use the frequency instead of the volume. For instance, the distance could be mapped logarithmically to a continuous range of frequencies or to a music scale like C minor with many octaves, which could make it sound contemplative. What do you think? This is one question.
Okay.
Yeah, Stefania gave an answer here. Let me just complete so that you know the whole thing. Hi, David, we tried this, but this would mean that the information about the magnitude is easier to understand with the here than with the side. We wanted the two stimuli to be perceptually equivalent.
Yeah. So there is also Stefania here. I think that also if she wants to say something.
Yeah, the last part that I read was was her comment exactly.
Okay, yeah.
So you have lots of claps on Facebook as well. So you have people saying very interesting. So yeah, amazing. Which enough are you from, Federico?
So I'm from Padova and Bologna.
In Bologna. Okay,
Yeah.
the Bologna team. Okay.
Yeah.
Well,
but so the Stefania and I work in the planetarium, and also in many other. So for example, now we are working also in to realize some little tablet like here, more or less, that represent not only the sky but only one constellation, but with the same information, with the same structure.
oh, that's another very nice idea.
Yeah.
Well, I love it. I think that bringing this to a classroom where normal visual and visually impaired can work together and, you know, build the knowledge about the constellation, do some research using robotic telescopes, and then, yeah, well, popping up ideas here. We will certainly contact you.
Okay, thank you very much.
And if I may make an invitation to people to watch David's workshop, that is just after the roundtable, that will be in Portuguese, because he will explore the sonification aspect. So I think it can be an interesting potential.
Yeah.
Yes, I remember, Federico, we were at Toulouse, right? At the CAP conference.
Yeah, exactly.
Yes, I remember you there.
Exactly.
Well, thank you very much for sharing here. Gustavo, I pass the floor to you.
Yes, it's time for the break, but it was really, if anyone else wants to comment, we have a few minutes. But I'd just like to say that after the break, we are going to have a round table, but it will be in Portuguese, okay? So we have this year some sessions that are in languages, not in English. Yes, Rosa, you want to say something?
Gustavo, but we can turn on the automatic translation, right?
We can try, yes.
Yeah.
Yes, we can
Let's try.
Why not? Yes.
Make sure this is available for those of you. I have to say that what is being presented in this roundtable is really very interesting.
Yes, of course. And I know that people from Spain and maybe from Italy, they can catch up a little of Portuguese, and it will be in different flavors of Portuguese from the different continents. And after that, we have David's workshop. So David's just below me or across me, I don't know, depending on how your Zoom is configured. That will be a sonification. So those will be the final two presentations in this session. So thank you for all the presenters. Thank you, Federico. And we have a short break, and we'll be back in 15 minutes for the roundtable. So see you soon.
See you all soon.